Hello, welcome back. Now in this debugging lecture, we're going to see how SMC instruction works at exception level 1. Here, what you can see is the panel. The first panel is register window, and the next one is the instruction window. So important thing you can observe is the current exception level is exception level 1. Please look at this. The EL1H represent the current exception level. Now, so at this point, the program counter is corresponding to the gray bar. So now we are about to run SMC assembly instruction. So right after I run this assembly instruction, please pay attention to this icon, because this icon will be updated to exception level 3. Now, I will click the start button to run this assembly instruction. So please pay attention to this icon. Here we go, 1, 2, 3. Please look at this. This icon was EL1H. That means exception level 1. But as you can see now, it is EL3H. That means the current exception level is exception level 3. And another important thing is the program counter is updated to this address. This address is called exception vector address from the perspective of exception handling. So that means once you run SMC assembly instruction, that ARM core will generate the exception. Now, it raises another important question. Now, how the ARM core jump to this address? So in order to understand how it works, we need to understand the value of VBAR EL3 register. When the exception is taken to exception level 3, the ARM core refers to the value of VBAR EL3 register. And then, depending on the type of exception, offset will be added to the VBAR EL3 register. To verify this kind of feature, so let's navigate the menu from CPU. Please look at this. From CPU, you can see the power menu. I will choose system control and configuration. So here, you're going to see the value of the VBAR EL3 register. So please look at this. The VBAR EL3 register has this address. So this address is exception vector address when the exception is taken to exception level 3. So now I will copy the value of VBAR EL3. I will copy this value. So here is the exception vector address. And this value, as you can see, that is stored in this system register. But depending on the type of the exception, offset will be added to the value of VBAR EL3 register. I'm sorry, here this is the VBAR EL3 register. So based on this calculation, so we can you can calculate the exception vector address when running SMC assembly instruction. So here is the address of program counter. So this address, okay, this address is here in program counter. So you can now understand that why the program counter is jumped to this address. Now let's roll back SMC assembly instruction. For this, I will use this command, undo command. Now it is toward original state. Now the current exception level is exception level 1, and the program counter is pointing to address at exception level 1. As you know that this is one of the sub-function inside Linux kernel. Now let's perform SMC instruction again. Please look at this. exception level is switched to ER3 from exception level 1. Now the program counter is moved to this address. This is the exception vector address based on this rule. So in this debugging practice, you got to know that the ARM core generate exception when running SMC assembly instruction. During this operation, ARM core perform two tasks at the same time. The first thing is to switch the exception level from exception level 1 to exception level 3. At the same time, the program counter is jumped to this exception vector address based on this rule. For more details of how the exception vector address can be branched, so I recommend you to review the exception vector table in ARM version 8 architecture.